Okay, this is Unit 9, Acids, Bases, and Salts, Lesson 1. And the only thing we're going to accomplish today is we're just going to look at the properties and characteristics of acids, bases, and salts. Okay, let's get started. Characteristic properties of acids. First of all, dilute acids have a sour taste. And some examples of some dilute acids would be citric acid, which is found in fruit, acetic acid, which is found in vinegar, carbonic acid, which is found in soda, and boric acid that's used in eye wash solutions. Concentrated acids will burn your skin and eat holes in clothing if you get it on it. Most of your common acids are found in Table K in your reference table. And that's also going to be on the same page with bases and indicators, two other things that we'll be using in this unit. Aqueous solutions of acids are electrolytes, meaning that they have the ability to conduct electricity when dissolved in water. The greater the concentration of ions, the more conductive the solution is. Weak acids are poor conductors, which should make sense. And strong acids are good conductors. Now, one thing that we don't really cover in this class but might help you understand it, a strong acid completely ionizes in water. So what that means is if I have HCl and it's in the presence of water, okay, so we'll do it this way. So HCl plus water is going to cause this to ionize into H3O plus and Cl minus. So the HCl gives up a hydrogen which goes to the water and it becomes hydronium ion, which is an indicator that an acid is present. And this ionizes 100%. So you have 100% ionization with a strong acid. With a weak acid, you only have about 5% ionization, which if it's only 5% ionized, then there aren't any ions in solution, and we need the ions in order to conduct. So that's why weak acids are poor conductors, because they don't have very many ions in solution. Acids react with bases to form neutral solutions. It's a double replacement reaction, and it has a special name, and I did mention it when we did reactions. It's called a neutralization reaction. So in word form, it would be an acid plus a base yields a salt and water. So an example would be HCl and NaOH to yield NaCl and HOH. So remember, positive, negative, positive, negative. Positive goes with negative, so the Na goes with the Cl, and then the H goes with the OH to form HOH, which is better known as water. And these are all one-to-one, so we don't need any coefficients. Acids can also react with certain metals to produce hydrogen gas, H2 gas, hydrogen gas. This is called a single replacement reaction, and we already learned about these. We're just reviewing it again. And we use table J to determine if the reaction is going to take place. Remember that the element that's trying to push in must be higher than the element that is trying to push out. So HCl plus Na is going to yield NaCl and H2 gas. And here we have to balance 2 on the right, 2 here, 2Cl, 2Na. Okay. Acids cause acid-base indicators to change color. So an indicator is simply something that changes color in the presence of something else. So for example, blue litmus turns red in the presence of an acid, and phenolphthalein will turn from pink to clear in the presence of an acid. Acids have pH values less than 7, and they fall on the lower end of the pH scale. So 7 is neutral. Here's my acidic range in here. And what you need to remember is that as we go away from 7 towards 0, this becomes stronger. So closer to 0 is stronger, closer to 7 is weaker. They have the general formula HA or HX, where X is equal to an anion, such as Cl minus. And this we can put where X or A. So it's A or X is the anion. Alright, let's switch now and talk about bases. Bases are found in table L, common bases, and these are all strong up top, and ammonia, which doesn't look like a base because it doesn't end in OH, is still a base, but it's a weak base. So, dilute bases have a bitter taste. Some examples are antacids, soaps, ammonia-based cleaning products. Let's see. Antacids have Mg, so MgOH2 is MOM, milk of magnesia. Another one would be AlOH3. This is found in Maalox. Your soaps contain potassium hydroxide, KOH. So bases have a slippery or soapy feel to them, as most of them are cleaning agents. Not most, a lot of them are cleaning agents. And concentrated bases burn skin and eat holes in clothing. So notice some similarities here between the bases and the acids characteristic. Aqueous solution of bases are also electrolytes, like acids, and they have the ability to conduct electricity in water. Greater concentration of ions, just like acids, equals more conductivity. Weak bases are poor conductors, and strong bases are good conductors. And this is for the same reason, because weak bases minimally ionize, less than 5% in water, therefore there really aren't any charged ions, which is what you need to have the ability to conduct an electric current. Strong bases ionize 100%. Bases react with acids to form neutral solutions. Double replacement reaction. And it's called a neutralization reaction. So we have an acid plus a base yields salt and water. Here's an example, HBr. So this is +1, -1, +2, -1. So our +2 is going to go with our -1. So we're going to have Ca, and this is +2, Br, -1. So it's going to be CaBr2. And our HOH, which is our water. So we need 2 Brs over here, which gives us 2 H's for a total of 4 H's. So we need a 2 there. And I think everything is now even. Bases cause acid-base indicators also to change color. And 2 base indicators are red litmus turns blue and phenolphthalein turns from colorless to pink. These are the litmus paper and the phenolphthalein are probably the 2 most popular indicator tests, and you will have to know those. They are listed in table M under your base table in the reference table. Bases have pH values, and this should say greater than, please change that, greater than 7, and they fall on the higher end of the pH scale. So again, neutral, basic, and as I go this way, my bases get stronger. So a base with a pH of 14 is stronger than a base with a pH of 8. They have the general formula XOH, where X equals a cation, such as Na. So this could be NaOH, because Na is +1, OH is -1. And the last thing that we're going to talk about are some characteristics of salts. They are defined as neutral ionic substances. That have positive ions other than hydrogen. And negative ions other than hydroxide. They are composed of a positively charged metal or a polyatomic ion and a negatively charged nonmetal or polyatomic ion, with the exception of OH minus, which would then make it a base. So basically, the easiest way to do this, salts, metal plus, most of the time you're going to see it as a halogen, which is group 17. It could be another nonmetal, or it could be a polyatomic and a halogen, or it could be two polyatomics. That's usually what you'll see for a salt. So some examples. Here's a metal and a halogen, LiBr. Here is an example of a polyatomic and a hydrogen, ammonium chloride, NH4Cl. Here's an example of a metal and a polyatomic. I forgot about that one. And so we have metal and halogen, metal and polyatomic, a polyatomic and a halogen, or two polyatomics. So we could just put for this two polyatomics NH4NO3. So those are all salts. And salts are formed from, we already learned it, when an acid and a base mix, you get a salt and water. So they're formed from neutralization reactions. And they are, you guessed it, neutral. So an acid and a base yields a salt and water. The exception to the rule is NH4Cl, which is the salt of a weak acid. Because when NH4Cl is in solution, it doesn't break down into just NH4 plus and Cl minus. The NH4 plus, as soon as it is in water and it's in this form, will then subsequently react water molecules to form NH3 and H3O plus. Okay, moving on. An electrolyte, as we've already said, is a substance that dissolves in water to form mobile ions. And therefore conducts electricity. So we have acids, bases, and salts are all electrolytes in solution. And this last part is really important because NaCl solid does not conduct, but NaCl aqueous is conductive. So this part about being in solution is very important. Okay, that's it for lesson 1.